Now let's do the optimized approach. We know in string we have learned two patterns, sliding window and two pointers. Two pointers we use whenever we have to compare exactly two points, means left pointer and right pointer, like compare or calculate something, anything, but with exactly two characters or numbers. But sliding window we apply whenever we talk about subarray or substring, and here we want substring, so hence we will apply sliding window concept. Okay, second reason to use sliding window is, previously in the brute force approach, I am assuming you would have watched the part 1 for this video, brute force, where we were generating all substring and then matching ki this substring matching with this substring or not, after sorting or counting the frequencies. If they matched, then only we considered that as anagram. If not, then we kept on moving. So for this substring in previous case and second substring, we were calculating all characters frequencies again and we were matching it. But don't you think for this middle one we already calculated, then why we are doing that again, means repetition. Also previously we were using two for loops, but in sliding window we only use one for loop, and hence we reduce the time complexity from O of n square to O of n. So idea is very simple, like how in sliding window we initialize left and right pointer. Right pointer is always responsible for expansion and left pointer is always responsible for shrinking. But to count all frequencies, we need a map which will take care of frequency and characters of P, and we need a map which will take care of characters with its frequencies in another map. So there are two solutions using the same sliding window concept. First, where you can use two map, and second where you can use single map. The time complexity will remain same in both the map solution, but the space complexity varies, because in this case you are using two map, and the next one which we will discuss as well, there we are using only one map. So space wise that will be lesser, but it will be more difficult to understand if you directly jump onto that solution without understanding the solution for two map. So what we do first in the map called, let's suppose P map. In P map we will count the frequencies of all the characters which we want. Okay. Now in the S map we will maintain the frequency and character of S. Okay. So what R does, while moving or expanding, R reads the character, add the frequency in the map. Okay. Also we have to count these characters as well. Why? Because see here how many characters we want? 3. So here whenever R encounters any such character which is present in the P map, then we will say ki yes, we encountered one character, then the number of count which was 3 earlier, this we will reduce to 2, means reduced by 1 whenever character is found. Why we are doing? Because in this case for every substring, whenever the count becomes 0 from 3, then we can say as the count is 0, means all the required characters has been encountered in this substring, hence it is valid one. Okay, so following this idea, R has encountered C, we will go in P map and we will check ki hey, is the C present and is the frequency is greater than 0? If it is, means this character is required, correct? Okay, so what we will do in the S map, we will add the same character C with the same frequency, correct? And if this is required one, so initially the count was 3, means the required number of characters are 3. We have found 1, so we will reduce this to 2 and move this pointer ahead at B. Now again we'll read this B. What? Is this character's frequency in P map is greater than 0, means is this present? Yes, means it is required one. So if it is required one, definitely whether it is required or not, whatever we are encountering we will add in the map, but if it is required one, then count will get affected and we will reduce the count to 1, saying ki so far we have encountered 2 characters which was needed here. Okay, again now we will move this R pointer ahead at A. Again the frequency of A is greater, yes, means A required, so we will add and we will reduce the frequency, like count to 0. Now does this count 0? Yes, means can I say from left to right this string is a valid string? Yes, and hence can we add this length in my answer resultant array, because in this question we are supposed to put the starting index. So definitely R is not my starting index, left is my starting index. Yes, we will put in this case. Another reason to put the left without shrinking. Why? Because in sliding window we expand and shrink, but in this case we will not shrink because current length is 3 and the required length is also 3. So where we will string? Suppose initially our string was E, A, B, C. Suppose, okay. So definitely left will be here, okay, and right will be here. It will encounter E, but E is not required. So hence R will move ahead. Now A is required, so count will reduced from 3 to 2. B is required, count will get reduced from 2 to 1. C is required, yes, count will get reduced to from 1 to 0. Yes, now the count is 0. But do you think this one is valid? No, because we have to say the starting point of that what? Anagram. But do you think EABC is the answer, or you think ABC should be the answer? Definitely ABC. So even though the count is 0, you have to shrink your left pointer. But for what? Whenever the length is greater. So in this case length was exactly equal to P, so hence we need not to shrink, but in this below case we have to shrink because the length is greater. I hope you are getting this. So basically we are moving the right pointer ahead, correct, to encounter the characters and to make this count 0. And whenever the count is 0 and the length is also equal to P, then we can say ki yes, this is a valid substring and we can store this left pointer in our resultant array. So resultant will store this 0. Okay. Now what to do? We will not do shrink because the length is valid. We will do the shrink only when the length is invalid, but it is valid. It means we have to move our right pointer ahead. So what pointer, what character we encountered now? Can I say E? Yes. So E has been encountered, but now the length is 4. It means it is not valid. Okay. So now what we will do? We will shrink. Okay. From here to here we have encountered every character, but we are looking for 3 length. So now we have to shrink. But don't you think when we will shrink, we will move our left pointer ahead, we actually lost our C character? Yes. So can I say from B to A, C is not anymore? Yes. So do you think for this count should be 0 or count should be 1? Means count says ki 0 character I want, but in this case C is not there. So from B to E, can I say I want 1 more character? So count needs to be increased. Okay, logically it should be, but according to the code, how can we write? We will say ki if the character present at left pointer is present in map and frequency is greater than 0, it means yes, this character was the required one. As it is required and left is moving ahead, so whatever task has been done by the right pointer, left pointer will undo that. What the right pointer did? It increased the frequency in map, yes, and it decreased the count variable as well. So it will undo that. Left character will undo that. Means it will reduce the frequency and it will increase the count. Saying now from this left to right, the character, the count needed is 1. Means it needs C. Now as the count is 1, so we will say that this substring is not valid, and as the length is already 3, so means we cannot shrink it further. It does not make sense. So hence we will increase this R pointer ahead, saying B found. Okay, so it will increase the frequency to 2. Okay, but as of now what we were doing, B found, yes, B is there, yes, frequency is greater, yes, add it. But do you think this B is even required? No, it is not. So if we follow the same rule, present and greater than 0, then to we would have added, means then to we would have subtracted this count to 0 and we'll say yes, from this B to this B it is valid, but it is not valid. Hence the frequency of every character also matters. Means in this case it says only 1 is required, and here it says ki I encountered 2, means the second one is not valid. Hence to decrease this count, the common thing is ki SMAP characters frequency needs to be less than equal to PMAP's characters frequency. Let's read this together. SMAP's B frequency is 2. Okay. It says I encountered 2. It says I need only 1. If you are equal to me, I'll take that. But you are greater than me. like this character is not even valid. If I don't want you means I will not decrease my count. Count will still be 1, saying कि I still need one more character. Okay, means B was not that character which you were looking for. Yes, again we'll move this R pointer ahead at A. Okay, again the frequency of A will become 2. For this rule also, S map A frequency 2. Is this less than equal to P maps A frequency? No, means this A character is also extra. This was not required. Hence, again we'll move our R pointer ahead. Now, B's frequency become 3. This is also not required. Now, A frequency become 3. This is also not required. Now, C. Yes, this one was required. Why? Because if you will increase this, after increment also, S map of like frequency of C in S map is 1, which is less than is equal to frequency of C in P map, means this one is required 1, and hence when it is required 1, now we will touch and we will decrease the count, and hence as the count has become 0, means I can say ki yes, I encountered every character from left to right. But is this valid substring? Because for valid anagram substring, length needs to be 3 only. So now what we will do? We will shrink. Yes. So now when we will shrink, we will move this pointer ahead. But before moving, what is the character it holds? B. Is this present? Yes. But what is the frequency of this B? 3. It is more than the required. Means I can still lose this B, because I know going forward I still have greater B, because I want only one B. Even if I lose this, my B will be 2. Means in between I have enough B. Means I need not to touch this count. I hope you are getting correct. Yes. So now we will simply move this L pointer ahead by undoing whatever R did. What R did? R just increased its frequency. So I will reduce back to what? 2. Again for A also similar thing. The frequency is greater. So it will just get reduced back to 2. Okay. Now at E, E's frequency is 1, but as you can see E is not even there, means it was also not required. So we will simply move our pointer ahead at B and reduce its frequency back to 0. Now we encountered B, but the current frequency is 2. We want only 1, means this B also we can ignore, because going forward we still have one more B. Okay, so means we will simply increment this left pointer and we will reduce the B. We will not touch count, because for R also we have not touched. Okay. Now again for A also we will move forward and we will reduce the frequency to 1. Okay. Now remember this R is on C, sorry, this R is on C. Okay. Now if you see for B, B frequency is exactly 1, this is also 1, but wait, don't shrink, because now the length is exactly 3, which we wanted, and also our count is 0, means length is valid, count is 0, this one is valid. So now we will read this index, which is 0, 1, 2, 3, 4, 5, 6. Okay. So in my resultant array, we will add 6. Now what we'll do? We will increment the right pointer. Now we'll move ahead this right pointer. We will add the D here, but D was not required. Okay. Again, what we'll do? This length is greater, count is still 0. Now we'll shrink. Once we will shrink, means move the left pointer ahead, but the B character's frequency was 1, required was 1, means we are losing this last B. It means in future we want that. So for that we will definitely reduce it back to 0, but we have to increment the count also, saying going forward we lost one character which is required, hence B. Now what we'll do? We will increment the right pointer moving out of index, and hence we can say ki we are done with this loop. So in just O of 1, why? Because one pointer we run for right from 0 index to last index, and when my right pointer was moving ahead, at the same time we moved our left pointer also from 0 to n. Correct? In the worst case I can say. Okay. So left pointer also moved ahead, right pointer also moved ahead, only for one time. Did you ever find either left or right has came back again and reinitialized itself to run again? No. Means it is linear solution, taking O of 2n, which is nearly linear, means O of n solution only. But space wise we use two maps here. Okay, so first let's see the code for this, and then we'll see how we can do this in one map as well, and trust me, it is very easy. So here is the code. First, to store our resultant, like all the integers indexes, we want the resultant array, and the base case, if our s length, which is the bigger one, if this is a smaller, how can we find the anagram? Okay, so then and there we will return the empty result. Now we want two maps, S map and P map. In P map we will read all the characters from P string and we will store its character and frequency in the P map. Okay, we'll initialize the left variable and initialize the count with P length, same as example number 1 where count will be P length, which is 3. Okay, now we will start running the right pointer from 0 to last. One by one we will read every character with the help of right pointer. Correct. Now whatever character has been encountered by right pointer, what we did for that, we added in our S map, correct, and we checked in if that character is present in P map and the S map frequency is less than equal to P map, then only we decrease the count. Remember? Yes, means to touch the count either for shrinking or expansion, this condition needs to be true. Okay, and now what we'll do, this much code is for what? Shrinking. Shrinking means even though we found everything, but if the length is greater than 3 means we can shrink, and for shrinking we will read the left character with the help of left pointer, and also we'll check if that left character which is towards the left side, if that was also present in P map and its frequency is less than equal to, means that one was the required one, we cannot lose it. But as we are moving ahead, means we have to increase the count, saying in future we want this character. Okay, so we'll increase that, and also whatever right pointer did, what it does, increase the frequency in the map. Remember, so it will reduce the frequency in the map, and we will do left plus plus. Now next time even the length was 4, but now as we shrinked, again the length will become valid 3. So that's why we are not putting this in while loop, we are only doing for one time, which is if loop. Okay, after coming outside we'll check if the count is still 0, means we can say this length is 3 and the count is 0, means every character which was required we found that. So hence that left variable, wherever it is pointing to, is nothing but the starting point of anagram. So at the end we will return our result. So as you can see, time complexity O of n with for this to run, like to store every character in P map, correct, and here also O of n for right pointer. So in total O of 2n, which is nothing but linear only. So now we can run. As you can see, it passed. So now let's submit this code, and it has been submitted. Okay, so this one was faster one, yes, and this was the Java solution. I hope you understood the logic and the code, and here is a Python code with the same logic of using two maps. Okay, and using linear solution, means sliding window. And here is our C++ solution, if in case you guys are from C++ background. The same logic, I have not changed anything, all things are same, and we here also we use two maps. Okay, so this was our two map solution. Okay, it was easy, yes, but do you think the one map solution will be tough? No, it won't. The only thing is ki one map solution says ki we will have P map, okay, but we will not have S map. Okay, so how we'll maintain that? So we will have P map, okay, and with the help of P map only we will do everything without S map. Here also we will initialize our left pointer and right pointer. Okay, now as you know we only have one map and the frequency is greater than 0. Okay, so what I am saying, count to we need, for sure we need count. Okay, like previous one. Okay, done. So whatever character was needed, I have increased it. Okay, so now whatever character will get encountered, what do you think? I encountered C. If I will increase it, will I get some value, or I should decrease it? Correct, because if I'll decrease it and if the if it becomes 0, then I can say yes, everything found from C character. Yes, similarly when I will encounter B, it will also get decreased to 0. I can say everything got found. Yes, similarly for A, decrease to 0, yes, and whenever we encountered, we would have decreased our count also, correct, and count also becomes 0. So now I can say it is valid. Yes, and whenever we encountered any such character which is not even there, so for what we will do, the idea is add this in map, initialize with 0, and as it has been encountered and whatever character has been encountered by R simply does decrease the frequency. So similarly it will decrease the frequency to -1, and anyhow if the frequency is in negative, means that is not required. like you can think of that is not required, or you can think ki it has been unnecessarily added in this. Okay, meaning is same, not required, or you can think it has been unnecessarily added in our substring. Okay. Okay, and you know, left pointer will always undo whatever has done by the right pointer. Okay, so now what R will do, R came here, R encountered C, it will say yes, the frequency is greater for C. Okay, so it will get reduced, so we will reduce the frequency to 0, and as the frequency was greater means that was the required one, and if that was the required one, we will reduce the count also to 2. Okay, yes, now we'll move the right pointer ahead at B. Again, the frequency of B is positive, more than, like greater than 0 means this was the required one, and if it was a required one, what we'll do, we will reduce the frequency. Okay, okay, and also we will reduce the count. Okay, okay, so we are discussing two things. If you are checking this first in the map, okay, and then reducing the frequency, then the check will be like this, ki it should be greater than 0. But if you are reducing the frequency first, means it has become 0, but still it was valid, right? So you have to check greater than equal to 0. Remember, okay, don't get confused, this is same thing only. Okay, now we will move this right pointer ahead at A. We'll see, yes, it is greater. So if you are reducing this first, so you have to say, is this greater than equal to 0? Yes, it is. Okay, so now we'll see this one was valid, so we'll reduce the count, and now the count is 0, and also the length, which is by right minus left plus 1, is exactly equal to P. So I can say this is a valid one, and what we'll do in the resultant, we will add the first or starting index. Done. Now again we will expand, we will add this E here, as said, initialize and reduce the frequency, correct? But as if you will check here na, after, like first we are reducing it, so what we'll do, is this greater than equal to 0? That's what I wanted, because it is negative, so means this E is not required, means it is not required, we will not touch the count, and anyhow for E we did not wanted to touch the count, remember? Yes, and whenever, like we were touching whenever the character frequency is greater than equal to 0, so to not touch, it should be less than 0, correct? Hence that is why we made it like this, ki it will be negative. I hope you understood the reason ki why we have initialized this with 0 and why we have decreased it to -1. Okay, now what we'll do, as you can see the length is greater than 3, correct? So we have to reduce, yes, we have to shrink, means we will move this left pointer ahead, but before moving, what we will do, we'll check here, see, okay, is this frequency what? Greater than equal to 0, greater than equal to 0, yes, it is 0, means it has been, like it is not negative, right? It has been 0 or greater than equal to 0, okay? So even if it is 0, means it has been reduced by R pointer for sure, means before reducing by R, for sure it was positive, yes, it was positive, it means this one was required one, and as we are leaving this, so for sure we have to increment our count back, okay? And what R did, R reduced the frequency na, so left will undo that, so left will increase the frequency. Okay, now next time we won't shrink because the length is again back to 3. Okay, count is not 0, so hence this one is not valid one. Again we will increment this to B. Okay, B incremented means it will decrease the frequency to -1. That's what. Is the frequency is greater than equal to 0? No, it is negative, means this B which we have encountered just now is not required one, means if it is not required one, we will not reduce the count, it will still be 1, and if it is still 1, saying we want one more character, and for sure B is not that character. Yes, so now what we'll do, as the length is 4, again we will shrink. Yes, so we will shrink means we will move the B, but remember before moving we will check, is this greater than equal to 0? Means this B is not required one, means even when we will move this, we know in our substring we already have one more B, so means without touching this count we can remove this, means we will add the frequency back to 0, means increment it. Okay, now as this 0, if you will see here, we only have one B which is required, means we cannot lose this one. Okay, now the length is 3, again we will move our R pointer ahead, A encountered, reduce, but as it is negative we will not touch count. Okay, again we will shrink, move A, but A is negative, so we will only increase the frequency, but not touch count. Okay. Again, we will move this R ahead, B. Okay. What is the frequency for B? It is what? 0. So we will reduce the frequency. Now it is -1, means negative. This one is not required. We will not touch count. Similarly, we will move our left pointer ahead. Okay. Now we lost E. So means we have to increment the frequency to 0. Okay. Now we have move ahead. So now what is the frequency for E? It is negative, means this one is not required. Hence we will not touch count, but we will increment the frequency. Okay. Now again we will move ahead A. A we will decrease to -1 again. As it is -1, this is not required. We will not touch our count. Similarly again we will move it ahead, but before moving, what was the frequency for B? B frequency is negative, means this is not required, means we will just increment the frequency to 0, but we will not touch count. Okay. Again we will move this R to C. Now what is the frequency for C? It is positive, means we need this. Okay. We will reduce the frequency, and what is the, can we touch count? Yes, because this was the required one. Count is 0, means this is valid, but the length is 4. We have to shrink. Okay. What is the frequency for A? A negative, means this one is not required. We will increment and we will move this left pointer ahead. Now the length is 3, still the count is 0. This one is required. So hence the frequency, the index is 6, we will add it here. So hence by this idea, following this idea, only using one map we can do the solution. Just whenever we encountered any character by R, we will decrease the frequency and we will decrease the count, but decrease the count only when the frequency is greater than equal to 0. But if it is negative, means that is extra. We don't want that. And left will always undo whatever has been done by right pointer. So directly jumping onto the solution here also created result, base case and one single map, and in that map we will fill the characters and its frequencies for P. Okay. Now running the right pointer one by one, we will check, read the character and read the value of that character in the map. If the value is positive, means we will do the count minus, saying ki we want this because it is what? It is greater than 0, correct? Greater than 0. Why? Because first we are checking and then we are reducing. Remember, if we will reduce first, then we have to do greater than equal to 0. I hope you are getting both of this. Okay. Now, what is this? This is for shrinking. If the length is greater, means we have to shrink. So in shrinking, what we'll do? Read the left character and read the frequency of that. Okay. But as before reducing, we are checking. So if it is positive or equal to 0, means that is the required one and we are leaving it. So we have to increase the count, or else anyhow in both the cases we have to increase the frequency because we are undoing everything done by right pointer. Okay. And left plus plus for one time, because length is 4, again shrink 3, length is 4, failed, again shrink. So that's why we will not add this in while loop. And after all this check, if after this check means the length is 3, if the count is 0, means we will mention this left pointer as a starting index of the anagram in the result, and at the after coming outside we will run this. Okay, return the result. So as you can see, time complexity is same, but only the space complexity has been reduced. Anyhow, it won't affect your speed here, because we have only reduced the space complexity, and in interview, mostly interviewer preferred this solution. Okay, because you are using single space. And here is your Python solution, similar logic, one map solution if in case you are from Python background, and here is your C++ solution if in case you are from C++ background. So I hope you understood everything, and yes, with this we can go in our sheet and we can mark the very first question done. So I hope you all will do this question, and please do let me know in the comment section if you understood the brute force and optimized solution, and optimized one also, which one you will prefer, 2 map solution or 1 map solution. So I hope this video will help, and if it does, please do like the video and subscribe if not yet subscribed, and you can even refer to your friends as well if you feel the playlist and way of teaching is good for you all. And that's it for this video. Let's meet in another video with some more interesting questions and topics. Till then, keep learning, take care of yourself and your family too.